What's up, everybody? Welcome back. Today we're working on our collaborative Rube Goldberg machine, and today we're going to try to make like our first environment for our simulation to run through. So context is, when I was a kid, I went to Science World in Vancouver, Canada, and there was this like ball machine that sat outside the place, and it had all these like little slides and conveyors and stuff, and it was fun to watch like the balls kind of slide around and figure like, where are they gonna go? Are they gonna run into each other? It's just like kind of like fun. It like sucks into this like spot in your brain where you're just like, I just want to see the ball move. There's no good reason for it. It's just fun to watch it roll around. And I thought it'd be kind of fun to do something like that. That's like kind of like collaborative and online. And so I thought it'd be kind of fun if we designed this like system where people could like upload chambers in this like big 2D grid, and each chamber will like act on some balls that get like fed into it, and it'll like knock the balls around and then spit them out somewhere, and then like the next chamber handles the next ball, the same balls. And so you can have some sort of like fun like canvas of things happening where at each section there's something interesting, but on the whole you get to see where it goes. I don't know. It just like triggers the little spot in your brain where you're like, ball move, fun. And so like some ideas for like chambers would be like, maybe in this one you have like a cannon and the ball comes in here and it gets like fired out the side. And then in this one you have like some water and the balls float in the water, and like maybe every once in a while it like gets like flushed out and the balls all come down with the water. Maybe you have like a planet or something in here and the balls like orbit the planet and get like shot out the side or something. Maybe you have like a portal in one, and you like the ball flies in here and then gets like shot out the other one. Maybe you have like a gripper, and the gripper picks up balls and like drops them into a hole somewhere, right? All sorts of like things. And I want to make sure that like whatever we design is flexible enough to handle all of those things. But we also want some form of like consistency between them as well, right? So maybe we have some sort of like generic physics that runs on them, on all things, but environments can override them a little bit if they want, right? That's kind of what I'm thinking right now. And what we have so far is this like really rudimentary physics simulation where I have support for an object or a line with a normal. And if the ball hits that line, then energy is conserved and it bounces off it. And that's kind of fun to look at already. Like I watched this a little bit while I was testing it yesterday, and I was just like staring at it, and I was like, oh, that was like 15 minutes. And all it's doing is bouncing it back and forth. So I think the idea is going to work. And I think today's topic is we want to like get away from this like hard baked simulation and into the idea of chambers, because I think the earlier that we start trying to make a chamber that gets plugged into the system, the earlier we'll figure out like what the consequences of that are. And I think the physics is like enough that we should be able to design like a really simple chamber. So what I'm thinking right now is maybe we just try to build a chamber, like this world's simplest chamber, right? Maybe something where we just have like a platform, and the platform like moves left and right. The ball comes in and it might bounce off the platform. Maybe. Yeah, and so to do that, we need to be able to like render a shape. And so I think today I'm going to be focusing on how do we run like a simulation on the server side, because I want this simulation to run on a server that's running long term, so that we can see like the long term effects of the simulation, because I think that's more fun. But I want the drawing to happen like on my machine, because I don't want to like, well, it just makes more sense, right? Say we were to do the rendering on the server, right? Say that we give like very few pixels to this thing. We give it like maybe 256 by 128. How many pixels is that? That's 256 times 128 is 32,000 pixels, fine. And let's say that like maybe we give like a really low bit depth, like maybe 1 bit per pixel. So divide by 8, 4,000 bytes per environment. Say there's like 100 environments, that's already 500 kilobytes a frame, and each frame is running like, if we run at like 60 frames per second, that's like 24 megabytes of data per second. Sure, maybe you can like compress it, but the compression is going to only work for like things that are easily compressible, right? And that's only with, what do we say, 1 bit per pixel? That's crazy. And so I think what makes most sense to me at this moment in time is I think we're going to design our plugins so that they like kind of have like the idea of like a serialized state. So like we'll have like kind of like plugin and he's gonna have like physics, right? And he's gonna like run some physics, and this is gonna be called by the server, and then he's gonna have render, and this is gonna be called by the client. So I think the idea here is that we need to have some sort of way to get whatever physics did over to render on the client. That's the plan. So I think that probably it's going to be like WebAssembly module is loaded on both the server and the client. We're going to make sure that the WebAssembly module is below some certain size, and that way people can like maybe load like one asset and like move the asset around, and that's going to be very cheap to like move the serialized state between, right? All you have to do is like set his position as rotation, and then all of the like, actual hard work is done on the client side. That's what I'm thinking. Thanks for the prime, Nimmouth, and thanks for the prime, Sal, and thanks for the tier 1 McBabo, 69. That's a good number. Do you guys get it? 69. I'm sure you guys get it. That's crazy. Yeah, okay. So that's the plan. And so we could have gone in the other order, where we start by trying to like move physics into the plugin and then do rendering. But I think it's better to do rendering first, because then we'll have like a visual thing on the screen. So I think first we're gonna figure out how to do some rendering. We have to like build some form of WASM module that we can load and render something in the browser. And then once we have that, then we're gonna have to like figure out how to like get the state from the server to the client. And then we're gonna do some like physics connections. That is the plan. That's the plan. Okay, so step one. Load WASM module. Alt F4, thanks for the raid. What's up, you guys? What's up? Unfortunately, we just did the explanation, but maybe we'll give you just a very, very brief recap. Rube Goldberg machine. Ball, roll around on screen. Brain go, ooh, ooga booga. I like it when ball move around on screen, right? Yes. Okay. So the basic idea is that we're going to make environments for this ball to roll around in, and each environment is going to be controlled by some WebAssembly module that runs on some server. The server is going to like handle all of the physics simulation that handles like ball go from here over to here, and then like this module will have like a portal, and the portal will shoot the ball in here, out here, and it'll have like a planet, and like the ball will circle the planet, stuff like that. Then what we're working on today is trying to figure out so if we're doing simulation on the server, we still need to draw on a client somewhere so that we can look at it. And so today we're looking at drawing from a WebAssembly module on the client, then rendering physics, like doing some sort of physics simulation on the server, then figuring how to like transfer the state between them. Hand wavy. That's what we're doing. So we just started, and we want to get like something silly, like a platform that just moves back and forth on the screen. That's where we are starting. So we're gonna have to have some form of like chamber, and let's just like make a Zig module, I guess, and give him some sort of like function. So what? It's gonna be like render. Okay. We so far so good. What is he going to need in order to do his rendering? He's gonna need some sort of concept of like time. So either we could store like time since the last frame, or we could give him just like a raw timestamp. Let's think about that. I think I like the idea of delta. That kind of like tracks with everything else we've done so far. And I guess we're also going to need to have some sort of like initial state. I guess also we're going to have like somewhere to like store internal state, right? So if we have like some sort of platform that's moving back and forth, we're going to have some sort of like state. Are you making a game in Zig? I don't know if I would call it a game. It's a lot like a game. It has like physics and stuff, right? The ball roll around. Oh, this isn't moving because the server's down, because I'm typing in my screen instead. Yeah, I think it's more like I think we might as well call it a game. There's no input from users, but there's inputs from somewhere. Inputs from code. Okay, so I guess what are we gonna do to move a platform back and forth? We're gonna have like platform location, which I guess we will just make like a one-dimensional float for now, right? X position, go back and forth. Sure. And he's also going to have to know, like, does he have to keep track of his, like, times in any way? Probably he has to keep more reasonably, he needs to keep track of, like, direction. Yeah. So he's going to have some sort of, like, movement direction. And that direction is just going to be right or left. Simple. Right? And then every amount of time, he's going to move by some amount in some direction. And so this is kind of everything that is required to like run the simulation. So this stuff will probably get serialized in some way, sent from the server to the client. The client goes, okay, give me that state, please, and I'll work with it. I think, let's think about this for a second. When I construct this guy, I'm going to need to like feed him something from somewhere. So there's going to have to be some sort of like init function, and he's going to return some state pointer. That makes sense to me so far. And then when I render, I'm going to render with that state. So far, so good. And this rendering is not going to do anything. We're also going to like have like some sort of like step function. So I guess render actually doesn't take in a delta because there's no movement happening for rendering. Rendering's only taking the exactly right now, given your current state, what does it look like? Yeah, I think that makes sense. Okay. So this guy's just gonna return, he's gonna like WebAssembly malloc. So we're gonna use to import the standard library. And we're gonna say std keep WASM allocator. Maybe we will alias this somewhere. And we'll just say alloc.create state. Yup. I guess that means that this is failable. But from the WebAssembly API perspective, we don't have like this. I don't know if you can like run a function that in Ziglang that you define that returns errors. So we'll just say that he's gonna return a pointer, and maybe we'll say it returns an optional pointer so that we can null it out if it fails. Then if this fails, we return null. So catch return null, and var ret is equal to this. This is probably constant, and this looks like that, yeah. And then we just have to initialize him. So we say ret is equal to, maybe we will just initialize these two values here. And then we can just say this, and then return ret. Okay. Now, on each step, what are we going to do? We are going to have some sort of like built-in speed of the platform, which I guess we will just make what? We want to move one width of the screen per second? One, maybe even faster. We'll start with one. One seems fine. 1 screen per second. And we are going to move in our direction. So I guess we have to look at the delta. We say const movement is equal to speed times delta. Then we move the thing by that much. So we switch on the direction. Maybe we call this self. We'll call it state. That's fine. That's fine. And if it's going right, we say let me think about this. So we have like some walls and say we are like here, and we end up going through the wall over to here. We basically want to make sure that we I guess it depends on like how, like, what if we go through like multiple walls? Like say we move a lot, our delta's really big. How do I want to handle this? We move by some amount, then we check how far into the next room we've gone, and then just like invert our direction by that much or something. We shouldn't ever end up going over one full wall at a time, so I think it's fine. You could also do something clever, like you could do position %2. We have like one width of the room, but now this pattern is going to repeat every 2 blocks, and then if we are in the range of 1 to 2, we can just invert ourselves. Yeah, that makes sense, I think. Okay. So here are, I guess what we'll do is we'll set the platform location to movement here. I guess all we have to do is say if we're moving left, the movement is inverted. Yeah, that makes sense. And if we're going right, nothing happens, so we don't give a fuck. We don't give a fuck. And do we even need braces around this, or does it figure it out? I'll put the braces. That's fine. That's fine. And then we just do state platform location plus equals movement. We take the platform location, make sure it is in the range of 0 to 2. And if the location, if the movement is above 2, it's above 1, sorry. We just set it to 2.0 minus the platform location. Yeah, I think that makes sense. Yeah, easy. And I don't know, my gut says that if I work with all of this stuff in this like state pointer, I don't know how much the compiler is going to like factor that out into like register operations and a store at the end. It should, right? I think that like there are cases where you need to worry about like what if another thread interacts with this thing and I have to reload from memory. But I think that like generally, I don't know like the Zig language semantics that well, but I feel like it should be that, okay, well, we know that like we can assume that we're the only people accessing this. I think is like a general assumption that like functions make when they're working with pointers. So I think we're fine. I think we are fine. Okay. So when we render, we're gonna have to render to something. Now, I was thinking that there are a couple options here. One is that we could try to expose WebGL from the outside world into our container, or like little WebAssembly container. I think that that's like an option that I'd like to keep on the table, but not implement right now, right? Because like, what would that mean? We would need to expose like all of the APIs to set up your like vertex buffers, your vertex shader, your fragment shader. You'd have to like compile and link your program, and then also like usage from within the plugin would be like now every single plugin has to do like WebGL context program setup, and like OpenGL is like pretty damn stateful, so you would have to be careful that when like we as callers would need to make sure to like sandbox each application's WebGL state. It's just like a pain in the ass, right? A little bit of a pain in the ass. So I think for now, I think that let's start by just doing software rendering, right? We'll just give it a canvas of pixels that he's allowed to draw on. And, if plugins take way too long, then we can either just ban them, say, fuck you, we're not going to use your plugin, or we could just, defer the like GPU acceleration to later. I think that's reasonable. So hand wavy. What's like a good size to start with? Software rendering. Say we want to look at every. I guess if we were giving like a grid of pixels, it's also up to the plugin if it wants to actually look at every pixel, right? It could choose to only render a few pixels that it cares about. So maybe we can. Let's start by like we'll keep it like kind of small. Well, I don't know. Let's see kind of hand wavy what we get if we resize some window to some resolution. Let's just get a feel for like how big how big pixels are. So this is on the bottom. I see. Let's try like 256 by 128 because those are powers of 2. We love powers of 2. And if I like take like my pencil and I want to draw like, oopsies, that's the dropper, not a pencil. I want the pencil. Pencil? That's a paintbrush. Pencil. He's trying to draw in white. That's a lot of pixels, to be honest. You could do a lot with 256 pixels. Yeah, that feels like a lot. That's probably good enough initially. We can always increase it later if we need to, but that seems like a lot. In fact, you could maybe even go lower, but let's start there. So we, from the JavaScript side, are going to like allocate a WebAssembly buffer. Ooh. Okay, so when we were looking at WebAssembly a couple days ago, I think the mental model I built up was that, let's see. You have like WASM module. Okay, that's too big. It feels too big next. We zoomed in so much. WASM. And then you have JavaScript. Or C in the case of us running it on the server, whatever. This guy like feeds in some environment stuff, right? And one of the things that he could feed in is like the concept of like some memory, right? He could be like, here is a buffer, and you can like work with this buffer if you want. And then in the WASM module, he goes like, okay, so you said like use this memory buffer offset by like 10, etc. But I think that when we were playing with Zig kind of worked under the expectation that all pointers pointed to this memory block that he defined. So we have to be a little bit careful here. Because like we don't really know if everybody's going to use Zig, but we can maybe say that like what Zig does might be a sane default thing to expect. And if another language doesn't expose this thing, it's like you can like, I'm sure that there's going to be some way in most languages to create a WASM module that exports some memory. I think I also saw that there's like support for like 2 memory systems, right? So you could feed in this and have this around, and then just manage which one you're looking at depending on context. But I think that I also saw that that's not like standardized and fully implemented or like fully supported, or like maybe it's supported by browsers that matter but not like fully part of the standard yet. Who knows, right? So I think for now I'm just gonna like look at what Zig does and use that as my default, and then we can always adjust later if need be and figure it out at that point. So I think that if we are working under the assumption that Zig is going to own the memory here, if we want to say here's a buffer where you can write pixels into, we're going to have to ask Zig to give us a buffer of that size, right? So we're going to have to say like pub export function alloc u8 array. Alloc, maybe we'll just call it alloc. That's probably fine. And we're going to ask for some size. And the size is going to be a U size. Sure. And he's going to return some pointer. Ooh, this is a little tricky. Yeah, this is what we decided when we were playing with this last stream. So you can't really just return a pointer like this very easily. I wonder if we can prove this easily. Hold on, let's see. Let's alloc size, and we return this. And can we do this for now? Here, we'll just say catch panic. Just to proof of concept this. Read declaration of alloc. Oh fuck, we can't call this alloc. That's annoying. I guess we'll alias is something else. We'll call this WASM alloc. That's fine. That's fine. Then we can call the function alloc, and then it doesn't matter. Okay. Zig build. Oh no. WASM no entry. Here we go. Thank God we have the fucking target still in here. I think you might be able to get Zig to use imported memory using the import memory flag. Oh, interesting. Let's take a look. Let's take a look. Import memory. Okay, so this looks like, I'm going to assume that the imported memory, though, is still the only memory. right? So he can either choose to use one big chunk of imported memory or one big chunk of his own internally allocated memory, but not both, would be my assumption here. But I could be wrong. Either way, I don't think it really matters, but it's good to know. Thank you for that piece of info. Okay. So if we build this thing, he's mad that this exists. Fuck. Okay. We have to return a pointer to this thing. But that's hard to prove. So, okay, we went through this whole ordeal the other day, but basically returning complex types from Zig to WebAssembly is like a little bit complicated. It might like decide that it's going to like turn this output parameter into an, or this thing into an out parameter. It's just a pain in the ass. So what we found was easier is if we say, hey, we're going to return a pointer to a thing, so which requires like a double allocation, which kind of sucks, but it made the rest of usage like a lot simpler, because if you're going to return like some sort of like complex struct from here, it makes it really easy to then make a function that's like get thing from struct that takes in a my struct and returns like an i32. That makes like that workflow really easy if you need to interact with like an object from JavaScript land that was allocated in Rust land. It just makes that easier. So I think we can follow this pattern for slices, because the slice is not just a pointer, right? It's a pointer plus a length. So this is now just a pointer that points to a thing that's a pointer and a length, which is like double indirection, which kind of blows, but it's fine. We'll live. We will live. Okay. So if he fails, he returns null. Fine. And this is now going to be ret slice is this. And then if we want the actual return value is a, oopsies, this should just be alloc here. And this should be wasm alloc dot create a pointer to a u8 like this. And we can catch this and say return null, and then we say ret inner is equal to slice. Return ret. Okay. That build? Not quite. He doesn't like division between F32 and comp time float. Sign integers and floats must use rem or mod. Fine. Fine. That makes a lot of sense, actually. So platform lock 2.0. State dot platform lock. Yep. And he doesn't like the allocation here. So alloc. Here we say, hey, we are allocating U8s, please. He doesn't like this because, what the fuck? Oh, it's like this. I see. There we go. Okay. Okay. So, okay, so when we render, we're going to be taking in pixel data, which is a U8 slice. I guess we can assume that it's valid, I think. We can null check on the outside, and we're gonna have to say like canvas width and canvas height. Okay. So we are going to render the platform at some constant height. Let me think about this for a second. So what if, like, how does the plugin know the aspect ratio that we're allowed to work in, right? Like, he's like got like some platform here. How does he know where like the top and bottom of the world are? Because that might be important for him to do his physics calculations as well. It's almost like we want to maybe initialize this thing with the chamber dimensions. At the very least, the chamber aspect ratio. But maybe we don't care about that for now. I guess. Yeah. Let's overcomplicating things maybe. Yeah, fine. Chamber. We'll call this chamber aspect, and he will store that here. And here we will just say that the chamber aspect is equal to chamber aspect. Okay. Not that it's like really that important for this guy. In fact, maybe he can just ignore it. Yeah, okay. I'm not gonna worry about this right now. I think that it is something that will be important later, but for now we can just ignore it, and I think it won't be a problem. So maybe we will just set the platform. I guess we need to like somewhere say at the very least const platform height. We'll just make this like 0.3 or something. Doesn't fucking matter. It just needs to be consistent between our like physics area and our rendering area. And then we'll just say that the pixel data will be kind of top to bottom, left to right. So if but the coordinate system of the world has like 0, 0 in the bottom left. So if we have our platform at 0.3, it's going to be like canvas height minus platform height. Okay. That's going to be times canvas height, I guess. So this is going to be where it is, which line the platform is on. So we can say for, maybe we give it like some thickness to it. Maybe we give them like 3 pixels of thickness. And then we give him some width. So we'll make the width like, I don't know, 0.3 as well. So this is actually confusing because this is not the height of like how fat the platform is, but this is how far the platform is off the ground. So we'll call this platform Y instead of platform height. Then we can say that for, we're gonna look at our like location of the platform minus platform width over 2. So we'll call this the platform X start. And the platform X end is just the start plus the platform width. Boom, easy. And then we iterate for platform X start, platform X end. We get the X position, and then we have like an XY. And so now we can convert that into like a pixel data pointer offset. So we can say Y times let's think about this. Platform Y. I guess we should call this normalized to make it clear. Which means that this start and end actually have to be converted to pixel space as well. So we'll say this is the normalized position for both of these. And the platform width is also in normalized space. And then we have to convert this to pixel space. So platform X start pixel space is platform X start norm times canvas width. Boom. And this is the same for end. And this is end as well. This is going to get mad at us because these like widths are going to be our U sizes. So we just have to say const canvas width F is a float 32, which is a float from int on canvas width. And we'll do the same for the height because I'm sure we'll need that. Okay. So this guy gets some F's appointed, and I think we're chilling. So this is in pixel space now. And I guess in pixel space, we actually want these to be U sizes again so that we can index into stuff. So here we'll do a int from float cast, on both of these. Boom, 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 boom. And we had to do the same thing for, this is going to be Y offset. Cool. And so our Y position is going to be canvas height float, which is the bottom pixel, minus platform Y norm times canvas height F. Okay. And then this is int from float to get us back into U sizes so we can index. Yup. And then YPX, we need to add the offset. Boom. Chillin'. Okay. So now we just have to figure out our pixel row. Start is Y pixel times canvas width. Boom. And then here, we're just going to draw from pixel row start plus X. Yeah. Pixel data at this place is equal to 0.0. Make it black. Maybe? Might be good enough. I don't really know, but we'll see. This is easier if we do ypx plus equals y offset here and make this variable. Just makes the casting simpler. Okay. All right. Comp time float and int doesn't like that division at 61. Can I just do 2.0 here? Fix it. And then here we need to dereference. I don't quite get the today's topic items, especially the last one. Oh, right. Okay. So we're basically trying to like render a chamber that is like simulated on a server but presented in a client, right? So instead of trying to find some sort of like intelligent compression mechanism where we render a full picture on the back end and then send it to the front end, I think what makes more sense is we just make the generator of the image run on the front end, right? So if we were to do some sort of like crazy procedural, like imagine that we have a chamber where somebody wants to draw that we're in space, right? So maybe they're going to like have some sort of like intelligent procedural generation of like stars that are like kind of sitting around here, right? We could like generate these stars on the server and then attempt to like JPEG compress them and send them to the client, or we could just generate the stars on the client. So my thought is like the generation of these things are going to live in some binary blob of code, WASM, right? And that's like, if these are procedurally generated, that's like a super efficient way of encoding that information. Like super efficient, right? Even something like as simple as if we wanted to draw a sprite, right? Maybe there's like an image encoded in the WASM module, and we only need to send that image one time when we like initialize the chamber, and then all of the future renders of this guy are just like position rotation deltas, right? Which are very cheap to send over. Render ball function. The other way around, actually. The ball is like managed by the simulation, but what the ball what the world is rendered by the chamber, right? So you can imagine that there's all sorts of stuff that the chamber might want to render, like a gripper that's like picking balls up off the ground, or like maybe I was thinking one of them that would be kind of fun is if we like made like a version of Mario versus Donkey Kong where you have like the barrels are rolling down here, and then you have like Mario standing up here and he's like trying to jump over all the balls as he climbs up. So like something like that, this Mario would be like managed by the chamber rendering. And like then they would be able to render animations like, oh, he ran into a ball, so now he dies and he makes this face and he falls off the screen. All of that is rendered by the chamber itself. Does every chamber get its own thread? I think that I'm going to limit the number of instructions that a chamber can execute in order to do both rendering and simulation. But we'll see. They aren't going to get their own threads, probably. We're probably just going to try to compute limit them and just ban anybody who takes too much compute. Not anybody. We'll just like delete modules that take too much compute. That's the plan, at least. Okay, so this is getting compiled, which kind of indicates that we can do something. I would like this WASM compilation to be part of like the Zig build system, so I wonder if we can do that. How do we do that? So we have like some compilation command that we're running, and I assume we can just convert this into something that runs in buildzig. Boom. So here we're gonna say const executable is we're gonna call this chamber is some executable. And the target is going to be, I wonder how we like, can we construct a target from this thing? Resolved target. How do we resolve target? Gross. Okay, never mind. I'm not going to do this right now. We're just going to compile it by hand and then spit it into the resource directory for now, because this is too much work. So this guy, oops, where did I go? Here. Here. We just slap this WASM module here, and we see what happens. One trashy spam chamber could ruin the whole experience. Yeah, I mean, I think that I'm going to manually validate them before I accept them, right? So what I'm imagining, since we're talking about it, is there's going to be some sort of like UI where you have like, upload, and then like, you shove your WASM module here, and then I will get like some sort of gallery of different modules where like the simulation of each module is like running, and we can do some validation that says like, okay, so like 400 balls went in the simulation, how many balls came out, right? And we can say like, okay, so each step of the rendering, how long did that take? Stuff like that. How big is it? We can like do all sorts of validation before we even get to the point where it's shown in the gallery. And then I'll have a gallery where I can like manually go in and click stuff, right? Because you're never going to solve the problem of somebody drawing a massive penis above my head, right? Because like I'm not going to solve that in code, so I just have to solve that by looking with my eyeballs. And so it's probably going to turn into a game where you guys try to hide penises in the module without me noticing them, which is going to be annoying, but that's a problem to tackle later. In fact, me saying that is a really bad idea because now that's for sure, it's like a self-fulfilling prophecy. But anyways, somebody linked buildzig for WASM. Oh, thank you. Yeah, that looks reasonable. Nice. Yeah, this is perfect. WASM freestanding. Okay. Okay, so there's a resolve target. Then you have to make a cross compile target. Okay, yeah, that's nice. Thank you. Okay. Okay. Build zig. God, I love the massive benefit here of just being able to be like, I don't want to do this thing, and then somebody just posting in chat that they did it. So sick. Because when I'm working by myself, I just have to do that thing later. We'll call this chamber. The name is chamber. He comes from source chamber.zig. And then this all stays the same. This takes in. Do we want to force an optimization level? Maybe we will later. Like, yeah, we'll just leave the default optimization for now. This is chamber entry, and this. Okay. And then eventually we're gonna have to have some way to like automatically move this thing into here. I guess for now, can we like soft link? I wonder. Probably won't. That won't work. Soft linking. I doubt the server will pick that up quickly. So we'll just copy paste it for now. Okay. So we need to load this WASM module, which I've already forgotten how to do, to be honest. WASM instantiate streaming MDN. I know this was like 2 days ago, but we're forgetful over here. Okay. So, right, we need to give him some imports. I think that we don't have any external dependencies on this module. So we should just be able to instantiate this thing with no arguments, and then we'll be fine. So we're going to change this init method to be render because he's calling himself in a loop. And then we'll make a new function init, which calls render one time, but then does our WASM loading here. So we'll do something like, we're going to want some sort of like global chamber that is instantiated by init but accessed by render. And this is just going to be fetch chamber WASM, and with no import object. And then we need to like await something. Here, we'll copy this. Boom, boom. No import object, and then we can just say that like chamber is equal to the obj. There we go. Okay. Let's just see how fucked that gets us. Because surely this won't work well. Surely. Yeah, okay. So network error when attempting to fetch resource. Okay, I'm actually gonna disable the rendering for now because it's gonna be fucking annoying. While we're just trying to get up and running. So this probably just says not found or something. NS error reset. How do I? Oh, it's because I fucking typed simple WASM and this is chamber. He still doesn't like that actually, which is surprising. Right, unimplemented. Okay, so he's probably saying unimplemented because he probably doesn't know how to set the MIME type on this thing. Would be my guess. Yeah, it's probably this one. We should have written logs for our failures, but get fucked us, I guess. So here we need to make a new extension type WASM. And here we need to return some sort of content type for it. So WASM content type. What else? Text WASM is my bet. What do we think? Content type WASM. Hello? What application WASM? Okay. Okay. I was close. I thought that because I see text HTML, text JavaScript, I assumed that WebAssembly would also be considered text, even though it's not really text. I thought that we might be using text in terms of the like ELF header way, where text actually means code for some fucking reason. The dot, the and dot looks pretty cool. Yeah, it's pretty sick. This is like a really cool Zig trick that I like discovered. I don't know if like discover is the right word. I like found at some point. That's pretty cool. Yeah, because you can then just use any string as a field name, and then you can ask you can use compile time processing to like figure out which field is which, and then it's like turns into a number, but you can switch on this thing like it's a string. It's pretty slick. Pretty slick. Okay, does this load now? Yeah, okay, so this loads now, but it doesn't do anything. So let's, maybe we'll open a second window here so that we can run the server and edit our JavaScript at the same time. So maybe we'll start by, can I put this in curly braces so I can do like console log chamber? Yeah, let's start there. We'll start there. So we have a chamber thing, and we're supposed to use instance exports. And what's in there? We have memory, we have render, we have step, and we have alloc. Didn't we have an init function? I thought we had an init function. We didn't write export on it. So we say zig build, and then we zig build and copy zig out bin chamber wasm to source res chamber wasm, and then yeah, that's fine. That's fine. So now we have our init function. Cool. And do we know what it takes in? I forgot already. It takes nothing. Okay. So the first thing we have to do is we have to initialize our chamber. So we'll call this chamber state, and we'll just say chamber state is equal to chamber instance exports init. Yeah. And then maybe we'll do a little bit of like a log state thing here. Just to prove to ourselves that it's working. Which means that we need actually export a function if we want to see something. So we'll say pub, what is it? It's a extern function log. And he takes in what we will just say that he takes a string. Can we log a string easily? I've already forgotten. We have to do something like this, I think. He takes in a string and a size, and then on the other side we have to do this like bullshit conversion if I remember correctly. We have to do like a function, WASM log. He takes in s and ln, and this is function in this language. Okay, and then we had to do something like convert it. Let's see if we still have that code somewhere. Index.js, did we do it? I think you have to like get the memory. Oh, this is logging I32s, which is not helpful. We have to like get the memory and cast it into like a text encoder, text decoder. This part. This is gonna look a lot like what it's supposed to be. So we have the memory buffer from our chamber. So it's gonna be chamber exports memory buffer. Chamber instance exports memory buffer. That sounds right. And then we are going to look at the data given to us for some given length. Yes. And then we decode that thing into a string, and then we console log the string. I think that's what we did. And then we have to pass this thing in. So we have to say that we have some sort of like import obj is equal to something. We have to pass this into the WebAssembly module. So it's basically going to look like this. So I think it was in Zig, I think they're expecting env to be the top level thing. And then we call this log. And he takes in, we just say this is WASM log. Yeah. I think that's right. And this we pass in import obj. And then do we have to write that this is const or something so that like the JavaScript doesn't get mad? Like JavaScript will ever get mad at anything we do. Okay. So let's make sure that our log, maybe what we'll do, right? Yeah, we'll log this here. So we'll just call log, and we have to make up a buffer to like print. So how do we do that? We say buff is 100 bytes, which is plenty good enough. This will allocate, if we remember correctly from the other day, this will actually create some WASM memory. They have like a stack pointer in our like chunk of WASM memory, and this will like move that stack pointer up, and then any writes we do will like go into that memory, which is like, so this is very actually in WASM land, like stack allocation and heap allocation actually are like not that different. I guess it's the same as real processes too, though, because it's all just memory. But like, it's still working from this like WASM defined blob. And so you're just, the only difference is that you don't have to like manage the fact that you could overwrite yourself. You can just bump the stack pointer up. We could say std format buff print. We say I'm going to log this shit into the buffer. And we just say, please log my state, please. I said please twice because I want to be really polite to him, so he actually does it, you know? Oopsies, I just accidentally closed that window. How the fuck did that happen? How the fuck? Oh my god. Oh god. Here we go. And we have to buff print that into this. And let's just do a catch and panic, because I don't think this will ever fail. And then we have to log that thing. So to print is this, and then we just say log to print pointer to print len. Boom. You don't have to put a let const in front of a variable in JavaScript when not in strict mode, but it's preferred. I feel like I want to be in strict mode. That sounds fun. I like it when it yells at me a little bit. That's kind of nice. I like it when I like use the language at least like kind of correctly. Okay, so after we create this state, I guess we want to log it, right? So we want to do like chamber instance exports log state chamber state. And we're hoping that that prints something. We're hoping. Fuck! We need to coerce the slice type, so this needs to be ampersanded, which means this has to be mutable, which actually makes a lot of sense. He doesn't like this being coerced like that, so this actually has to be, we'll just say that this takes in one of these and then everybody's happy. We probably want const here still. And he actually doesn't like that there's a function signature mismatch log. Oh, so maybe I actually have to, I can't call it this. Maybe we have to call it log WASM. Because log might be like a built-in word or something that we're not allowed to use. I think we hit that the other day, actually, if I remember correctly. Yeah, he's fine with that. Okay, so now we go into here, and did we log our thing? We did, so if we refresh, that's a really good sign. That's a really good sign. So we have some chamber state that we have allocated in Zigland, pushed over to JavaScript, and then used in JavaScript to call back into Zigland, and he's doing something. So that's sick. That's sick. We're on the right track. So now let's step by some delta. So how are we going to do this? I guess on render, we are going to do something. Let's just ignore the whole simulation right now, actually. Let's just do render chamber instead, because I don't really give a fuck about like what's happening on the server right now. As we get up and running, who gives a fuck, you know? Render chamber. And so he is going to call step. So it's going to be like step with the chamber state and delta. How do we calculate delta? I guess we will just say that the delta is 16 milliseconds, and we'll just call this every 16 milliseconds. Fuck it. Blaze it, you know? I gotta stop saying blaze it. It's so fucking stupid. Okay. This delta is in milliseconds, so it should be like this. 0.16. Which part of the browser executes WASM, the JS engine? I actually haven't looked at that before. I'm assuming that JavaScript calls some sort of like internal browser C++ API that like compiles or just in time compiles the WebAssembly module, and I assume that like the JavaScript engine will go like, oh, he called this function, I have this built in for that, so I'm going to go over here and run like that thing that I just in time compiled. I assume it's like, and there's probably some sort of like data marshalling between those guys that's a massive pain in the ass. But I've never actually looked at like implementation of like JavaScript engine, so I'm just guessing, but that seems like a reasonable guess to me. Good eye on we should only do this after this thing is initialized. You are correct. Because that was going to be a pain in the ass. And then, so we say step this thing by that much, then do it again later. And now we just want to render the thing as well. So we can say chamber instance exports render with chamber state. We need to feed it some pixel data. So we need to get the pixel data from our canvas. So we can say like, where the fuck am I? Here. If I remember, I was like looking at this before stream, and I was looking up like, can you just get pixel data from a canvas? And I think there's this pixel data structure somewhere. Pixel manipulation with canvas. And yeah, they make an image data. And then I saw I texted my friend this morning, so I was like, what the fuck is a uint8 clamped array? You click on this and it's like, the typed array represents an 8-bit unsigned integers clamped from 0 to 255. And it's like, bro, every 8-bit unsigned integer is clamped from 0 to 255. What the fuck are you talking about? But it turns out it's like something about like JavaScript on set of values in this thing. If you set the value of like 256, instead of it wrapping around and setting 0, it will set 255. But like, what a confusing description for this thing, right? In what world is a uint8 not clamped to all of the values that a uint8 can represent? Silly MDN. Out to get me again. I actually really like the MDN docs so far, so I shouldn't complain. It's just kind of funny. Okay, so I think that you can... They have an example somewhere. And get image data. Is this what I want? I think I saw somewhere that you can create image data. Am I allowed to manipulate this thing from getting it? CTX draw image, put image data. This seems familiar. Okay, so we can, I think there's like create image data API somewhere. Create image data, and we will create an image data that is the size of the canvas, and then we will fill it from data that we copy out of the WASM memory, which kind of sucks. But I think that there's no way for us to feed the canvas data directly into WASM because I think that the WASM side needs to work in its like WebAssembly sandbox memory. So I think that's the best we could do is just work in that memory space, then copy it out into this buffer after. So we are going to do something like, do we want to allocate every frame? No, we just want to like get like chamber pixel data up front. So we're gonna do something like, when we first get here, we're gonna say chamber pixel data is equal to something. Something. We're gonna have to like get the canvas width and height. Unless you import the memory, sadly you have to copy data. Hard life. And even if I did import the memory, I don't think that I could make a memory buffer. Like even then, I think that I'm not positive that you could wrap. Can you wrap existing memory with WebAssembly? WebAssembly memory. Like, can I wrap an existing uint8 buffer with this thing, or do I have to create a new one? Yeah, right? Like, this doesn't look like you can create a WebAssembly memory out of some browser memory. You know what I mean? You know? So even then, I'm not sure. Maybe it's possible, but I'm not positive. Okay, so here we need to call our allocator. So we're just going to say document, nope, chamber instance exports alloc. And we're going to allocate the canvas width times canvas height. And if the canvas size changes, fuck you, right? And we are in control of that actually because we've hard coded our canvas width and height in the HTML. So it actually can't happen. So we're actually chilling. And so now we can render this thing with the canvas chamber pixel data and our canvas width and canvas height. And now that we have that, we should just be able to copy that out into like export 4 bytes per pixel, so multiply out by 4. Not in here though. In here we're working with it like it's grayscale, which might be wrong, like might be stupid. We probably actually want color. But for now, let's start with black and white, and we can always upgrade to color later since we've already written that code. For now, we'll do it this way. And so now we have to just extract the data out of that chamber pixel data. So what's a little confusing here is our chamber pixel data is not directly accessible here because it's a pointer to another thing. So we actually want to do something like, we want to like get the pixel data pointer and len out of this thing. So we can say extract pointer. How do I want to call this? Slice pointer, I guess makes sense. Maybe you can create a uint clamped array from the WASM memory and feed it to put image data. My gut when I was looking at this said that you need to create image data. And the create image data is like owned. You guys, you're saying you can? Okay. So that is something to look at later for sure then, because that's better. Because I thought that put image data takes, I thought that it took an image data, and I thought that the image data owned its read-only data buffer. Oh, but you can make it from a uint8 clamped array. Oh, wait. So we can actually work on this directly. Hold on. Let me think about this. Yeah. Wait. We can just do this. Okay. Because here. Okay. Hold on. My brain's like melting. So whoever said times 4, I'm now on your side. Times 4 here. Okay. Now we can somewhere let's say pub export function slice pixel data slice pointer, which takes in a pointer to a slice and returns the slice pointer. This is like a annoying side effect of how we've managed the memory here, but I think it's fine. So p is just going to return a uaid like this, and we're going to return p pointer. And then here we can say slice len takes in our slice and returns a usize. Yep. Okay. Yes. This is coming together. So here we've like shoved some pixel data in here. Here we need to multiply a bunch of stuff by 4. So canvas width f, just multiply this by 4 probably. So the start pixel is the start norm. Oh no. Yes, that works. Then this is, where is our like y pixel? Pixel row start, this is also times 4 here. Okay, so now this guy is going to work in this pixel data space. I think it's right. We'll see in a second. It might not be, but it doesn't really matter if it's not. It's good to just start somewhere and then figure it out later. At least for me, that works better for me. Okay, so now we're going to allocate this thing. I think you need to multiply the final thing by 4, not the individual xy. No, I'm like pretty sure here. I'm pretty sure. This is going to end up setting everything to 0, which is going to be a little annoying because alpha will be 0. So this we're going to have to adjust a little bit, but I think the rest is right. I'm like 75% sure. Okay, so now that we have like this chamber pixels data, we can say, hey, where is the pointer to this thing? Slice pointer to this thing. Offset is this. And the len is slice len. And then we can create a uint8 clamped array based off this. So it's like const array is a uint8 clamped array. I think it's right new. And we can just uint8 clamped array. We can just wrap the fucking WebAssembly buffer. Yes. Buffer. So buffer offset length. So this is chamber instance exports memory buffer. That's a mouthful, but we'll live. Then we have offset len. And then we should be able to just feed this into image data. So we can take this from this. So image data is a new image data from array with a given canvas width and canvas height. Where I assume this is in pixels, so width should be times 4, I assume. Like, I'm assuming that it will do the times 4 for me. Then we should be able to do set image data. Put image data, here we go. So this is just on the canvas. So we just say context, put image data with image data at 0, 0. And that might do something sane. It might not, but it might. Let's clear the canvas as well before we start. Fill. Oh, we don't have a fill rect example anymore. But that way, then at least if we're drawing all white, which is easier for us right now, then it should work out. If we just make the background black. So here we can do something like, instead of writing zeros, we'll write ones. And then we will ctx clear rect 0, 0, canvas width, canvas height. All right. Moment of truth. Moment of truth. Fuck, it doesn't even build. Not the moment of truth yet. It will be in a second. So he doesn't like that at 65. Oopsies, what the fuck did I just do? 65. Oh, this needs to return this. Okay. Moment of truth. What happened? Nothing is happening right now, which is not good. I guess maybe we have to set like the clear color. Okay, let's double check here. CTX. How do I like style, fill style is equal to black, and then we'll turn this to rect or something. I just want to see like the canvas do something at all. Wasn't there a exception? Oh, there was. That's a good point. That is a good point. So this is coming from inside render chamber. There's an unreachable in there. So I guess for now, we'll stub this out. Okay. Why is this gray? Shouldn't it be black if we did this? My eye? Oh, because I put image data. Okay. So I have to fill rect. There we go. There we go. Okay, we have a black thing. Cool. Now we should be able to draw the image data. Refresh. Okay, so now we're just putting all gray data on top, which is annoying. Can we fill the initial image data with zeros or something? Oh, that's actually really funny. We're seeing gray because in Zig, in debug mode, it sets every uninitialized piece of memory to the letter A. So this is just us seeing the letter A a bunch of times, which is actually a really good sign. That's actually like really, really good sign. That means that like it's the memory buffer exported by Zig is actually giving us something, which is very cool. Very cool. Okay. Chamber.zig. So I guess maybe when we first construct this thing, let's maybe get. Maybe we'll make a function here that's like function get chamber pixels. And then we can take this here and return this. Right? And then this can just be get chamber pixels. And then down here, when we first construct this thing, we can call get chamber pixels and then say, like, is there fill 0 or something? No, he doesn't like that actually. Oh, because we need to say it every fourth guy to 1. Is there like an efficient way to do that? Can you like uint30 data view? I think I want some way to like. I think if I cast this to uint32 array, then I can fill it with something else. Or can I just cast this to uint32 array? Uint32 array r, and can I just say like const u32 r is equal to this, and then can I just say u32 r fill with 0x ff00000. I didn't have to build that, but that he doesn't like that actually. Why not? Do I have to build it around the buffer maybe? There we go. Okay. Maybe not. Why is he mad now? Invalid out of range index at get chamber pixels. Out of range index. So if I just don't do this, does anything bad happen? Yeah, that's like totally fine. Why does this cause any problems? Yeah, I don't understand. Bum 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 bum. You need to pass in length over 4, maybe? Where? Like, here I'm saying, could I just like recast this guy? Let's see, okay, can't cast uint 8 array to uint 32 array JavaScript. Like, surely. Yeah, I don't understand why this is a problem. Like, this shouldn't affect anything, but it's changing behavior, but I don't understand why. You know? Then oh, this guy is saying to do that. But I don't really understand why. But we can try it. I don't actually have to build there, but play, refresh. No, that's still happening. I don't understand. So if I don't do this fill, does that break it? Surely not, right? Yeah, okay. So can I say like 0, 1? Like, what if I just fill like a couple pixels? That's also fine. Do we see any like indication that that did anything? No. Oh, maybe if I say like 10 pixels? No indication there either. Maybe I got the FF on the wrong side. No. Why the fuck not? All right, let's try it. Let's look at data view again. I feel like I just don't understand something like really obvious there, but it's fine. Uh, yeah, you're saying that there's like parameters for buffer by offset and length. I'm just surprised it doesn't handle all that automatically. Is probably my bigger problem. You can initialize from Zig, it might be easier. Yeah, but now I want to understand why. You know? But it's fine. So let's see if I just do this and I set 1 pixel. Do we see any evidence of that happening, doing anything? No. Why the fuck not? Maybe this isn't like behaving the way I expect it to behave at all. That could be related for sure. Let's do for how do you do like var x equals 0, I is less than like 100, like 1,000, I plus plus. Is that how you do for loops in this language? Just try this. It's just doing jack shit, which is very odd. We're calling allocate. We don't like allocate again later, right? Oh, we are calling render here, which might be doing something so stupid. No, because we return immediately out of render. No errors in the console. Yeah, does new do a copy? It might, but that surprises me. Like, I'm pretty sure that I've seen this before where you use the like underlying buffer this way. Data view. buffer. Maybe we use array, not array.buffer. Maybe that's where I'm going wrong. It doesn't like that. Data view expected array buffer got uint clamped array. Oh yeah, okay, so this should be array buffer. Okay, I'll come back to this off stream, I guess, because it's pissing me off, but I don't understand it. What does get chamber pixels return? Maybe it doesn't return anything. This returns a uint8 clamped array. So we should be looking at the uint8 clamped array. If we do like uint32 array, array.buffer, this should be taking in a uint8 clamped array, looking at the underlying data. This is an array buffer like, which is maybe interesting. But it's okay. I'll just not do this for now. We will just initialize it from Zig. Print the array variable. Fine. You're right. You're right. Buffer is an array buffer underneath. Yeah, it's fine. It's fine. I'll just not do this for now. Fuck. We will just work around it so that we can keep moving. So I guess we will just, when we allocate our thing, we will say mem set ret slice 0. It's fine. We'll live for now. We will live. Okay. So now when we construct this thing, we should be able, let's call render now and see if we can like see something happen. So we wanted to fill our rectangle with black. Why isn't that happening anymore? Is it because we're rendering white on top? We are rendering white on top, which is confusing to me. Because we tried to set everything in the slice to 0. Yeah, why the fuck is that changing behavior? Because alpha should be 0 here. It should be RGBA, right? Right? Am I high? Let's try doing something else. Let's just try to get any evidence of this doing anything sane. Right? We know that in its default state, it's showing a bunch of 0. Oh, the fact that it's showing gray, actually, is indicating that I don't understand the format of the buffer. Right? Well, what happens if we fill the behind with red? Is it just like kind of leaking through any red? No, it's just completely gray. So I thought this was RGBA data, but maybe it's not. Maybe that's where the confusion is coming from. How do I set the color space? Oh, I set the color space. I set the color space. What's the default color space? So here, okay, if you try new uint8 32 array with u8 array.buffer, it should not do the copy and actually change the underlying structure. Try fill 0xff000 to fill thread. I did try that, and it didn't work. So I was a little confused about that, but it might just be that I'm not correctly understanding a second part of this. So we could do something. We could do something like this. Let's try this. No. I was gonna say we could try making a new uint8 clamped array to check, but I don't really want to do that. I want to understand the parameters here. Settings. So if no such array was given, an image with a transparent black rectangle or width and height will be creative. So this is width, height, data settings, width, height, settings. And if we do not do anything, then it should be gray. Or it should be like RGBA. So if we do r fill 0, what happens here? Let's just start there. Okay, so it's fully transparent like I would expect. And if we r fill, let's just like do a stupid for loop for now. I is less than chamber width times chamber height times 4. I plus plus. We'll say r at I is equal to, here we'll do I times 4 is equal to f. This is plus 1, plus 2, plus 3. So if this is RGBA data, then if we put zeros here and f's here, we should get red. I plus equals 4, that's really good. No, I mean, this should work. So the fact that this isn't doing what we want either is very confusing to me. Right? Something about this is fucked. Can we say... remove the fill under the... good eye. Okay, that's very much not what I expected. Do I have to do our buffer here? Maybe? Yeah, what the fuck is going on? Buffer here? Like... oh! Oh! That did something. Oh, but we were supposed to be filling with red up here as well. Okay. So, okay, that's being filled by this. Here we should be using array, canvas width and canvas height. Here we're filling this whole buffer, I think. Right? Am I crazy? Like, console log array. Like, what the fuck is going on? Oh, so just after we set everything, it's just not doing jack shit? Okay. Why the fuck not? Hello? Like, am I allowed to use this thing like this? uint 8 clamped array. Like, how the fuck do I work with this thing? Yeah, they're just fucking setting values in it. Which is like, what the fuck is going on? Fuck! Seriously, what the fuck is going on? I'm so lost. What is, like, console log I? Right? Like, let's just get, like, really challenge our assumptions here. Is this loop fucking running? What the fuck did I fuck up over here? Like this? Okay. It does kind of feel like that isn't running, huh? It does kind of feel like this loop just isn't happening. So what the fuck is going on here? Oh, oops, yeah. Chamber width should be canvas. Dude, what a fucking stupid ass language. What a fucking awful fucking language. Okay. That at least gets us somewhere. Okay, we don't log here so that we don't like fucking freeze the whole fucking console. Dude, what an awful fucking language. Okay, so now it's red at least. And if I do this, refresh, hello, refresh. Oh, is it just fucking frozen because it can't loop over something that big? Okay, now it's yellow. So this does something. Okay, now we can at least challenge our test with const r u32 is a new uint32 array backed by the buffer of r, or of array itself. Here we should be able to do r u32 fill 0xff000ff. Now what the fuck did this do? This did not do what we expected, right? So what the fuck? Is fill not what I think? Value, start, end. So can I do like 0 to canvas dot width times canvas height? Is this where we were going wrong? Still nothing. Okay. What if I back it with R buffer? Refresh. Oh! There's something. Ooh, okay, wait. Times 4? Ah! We got there. We fucking got there. Okay, so this guy will take the inner buffer. Here, this fill requires a length to be given, I guess. It doesn't just, oh. No, that's actually working now. Okay, so this is working here. Now the question is, will this work down here where we were doing before? And if it does work down here where we were doing before, I don't know what the fuck we did wrong. Because I feel like we tried this exact combination of code earlier. But we'll see. Okay, refresh. Okay, so that's not working. So what the fuck is the difference between this and this? Like, what in the actual fuck is going on? Seriously. What the fuck is that? How is that any different? Because we shouldn't touch that memory again anywhere. And also, it's like fucking crashing with out of range index in get chamber pixels. Get chamber pixels called at different times, sure, but like get chamber pixels, all this does is access our global data of chamber, and chamber is only set here. So I just don't understand why this would ever be different. That's very strange to me. Yeah, just super fucking strange. Okay. Well, for now, since I don't understand it, I'm going to come back to this off stream for sure. But for now, we'll just do this. We will just do this. So we'll clear it with black. Let's just make sure that we get a black thing here. No. I guess it's the other way. Alpha first. There we go. We have a black thing. Chillin'. And now we should be able to call render on this thing. And let's debug this guy. So this was crashing earlier. And it's somewhere unreachable executed. And we don't really know where, huh? But we can start maybe debugging. We can start debugging. Let us think a second. We just bisect. Bisect is the simplest way. Oh, he doesn't like that. Fine. That's annoying, Zig. That's annoying. But I'm assuming this will cause no problems. Ah, fuck off. Okay, fine. Fine. We will get a little... We'll debug differently because I don't want to deal with all of that. Here, let's just start by changing this to a 0. Because I'm pretty sure this is where the bug's going to be. This is the only place that could cause real, like, fucking problems. So let's just say we just fucking... slam some 1s in there. Okay. That's actually still hitting an unreachable. That's surprising to me. So we could be hitting some bugs with like integer to float cast, like usize casts. It could be like any of this stuff. So let's just kind of whoop. Can we like... We can maybe guess here. This is... No, this is not going to be... Oh, built-in default panic. Is this going to log something? No. I wish we could like GDB the Zig. That would be nice. But it's not that simple. It's not that simple. Okay. Fine. I guess we will go piece by piece. We have to. We have to. No, 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 no. Refresh. We're chilling. We just have to start going little by little. This is equal to y offs. This is equal to platform x start norm. And this is x end norm. And then he doesn't need this guy discarded here, and he doesn't need this guy discarded here. We're still chilling. We are still chilling. These guys are also suspect, so let's look at these. There, okay. So it's one of these casts. Interesting. So I guess here, before we do anything, we can log these things as strings. So let's make a function log num, which takes in a number of any type. We call log WASM with our string. Which is going to be this is going to be s pointer s len. We have to make our strings. We say const s is equal to std format buff print into some buffer with our number. Ugh. Gross, but we will live. We'll live, and then we say var buff is equal to is 1024 u8s undefined, and we just go like this, like this, like this. And now we should be able to log the number. So we'll just log num platform x start norm. And norm the canvas width, and the canvas height. Why is the canvas width times 4 for x position? Because it's 4 bytes per pixel, was my thought, but maybe I'm an idiot. Possible. Very possible. He doesn't like this log WASM s pointer, or why? Oh, because we need to write try here. Or catch, like this. Boom. And then return. He needs a semicolon here. Refresh. Console. That's super cool. Love that. Because why the fuck is that failing? What the fuck, man? Index.js here, when we log WASM, we decode this like returned array with this string and length. We pass in the string and we pass in the length. Std do. Let's console log len is len. I hate everything, man. Everything's so hard all the time. You know? So here we got length of 41, length of 70 fucking 6. What? Why? Like, there's no fucking way. Did we hit something the other day with like a Indianness? No? These just come in like this. What the fuck is the problem? Is it that the lengths are... Oh, is it doing like some like I32 U-size casting? I'll bet you that's it. Here, our export functions need to say that this is a I32, I bet. I bet. I bet. There we go. No, these lengths are still fucked. So fucking stupid. Am I doing anything like brain dead here? No. It's just coming out as like an incorrect length. Log number. We take a number, we buff print the number into a buffer. Fucking simple. We call log WASM with that length. Also simple. So either buff print is giving us the wrong length. We could test this by running 2 here. We'll go back to usize here. So if we write 2 here, do we get 2? We do get 2 over and over again, which is good. Okay. Okay, so on our buff print, it's just giving us a number that isn't right? I guess, but that's insane. That's insane, right? Like, do we just not understand buff print? Zig standard library. Like, that just makes absolutely no sense to me. Buff print. He returns a slice. And usually thin wrapper returns a slice of the bytes printed to. Hello. Let's just write the word hello here. We write the word hello here. What happens? Refresh. Hello. Oh, he didn't compile. That would happen. Refresh. Why is nothing happening? Refresh. There we go. Okay, so we're closer. He's got the right length now, but he's printing out garbage, which is surprising. Quite surprising, actually. Can we go back to, like, when we did log WASM with a regular string? Oh, fuck me. Wait, hold on. Index.js. So when we call WASM log, which is where this goes, he looks at the export in memory with this offset and this length. We decode the thing and we log the thing. Stack being reused for something. Maybe move the buff outside so it's static. It's not a bad idea. Just temporarily. Not a bad idea. Still crap. Console log the raw bytes, also a good idea. Oh, interesting. That looks a lot like the pixel data. Which is kind of funny. A lot like the pixel data. So let's, where is that blue fill? Let's get rid of this shit. Okay, so if we don't log that blue shit, then if we don't do that blue overwrite shit here, then it's fine. Oh, sorry, that whatever color was supposed to be. So let's try limiting the size of this thing. Canvas width times canvas height. And then we need to fix this render call because that's causing problems. Okay. And do we still see hello? Oh, we can't, we do need to call render. Okay. So he's hitting an unreachable now at render chamber. Well, but that's fine. We should be able to see the numbers. Numbers are fucked again. Numbers are fucked again. Interesting. Very, very interesting. Array buffers the whole WASM memory, maybe. 800 times 600. That is a lot. That is a lot. Hold on. So this, we're pretty sure that the uint8 thing here is this isn't actually shouldn't be causing memory corruption. It shouldn't be causing memory corruption until something else happens. So it could be that the buffer that we're rendering into is just, like somebody said, stack overwriting feels likely to me. Can we look at like a console log offset is offset and len is len for the chamber pixels? Let's just see what it thinks those are. So here it thinks that we're offset by 117,11796, sure. Very long length, very high offset. And can we look at like the pointer address? You're saying put the length when creating the uint32 array. Oh, fuck me. Are you serious? Yeah, I could see that. Fuck off. So, byte offset. Like, is it something like this? Byte offset. Like, fuck me. Byte length over 4. Yeah, that fucking sucks. That's really, yeah, okay. I see what's happening now. I think. No, well, yeah, okay. Fuck me, dude. That's so frustrating. Okay, I understand. So, I thought that this buffer guy here was a, like, section of memory that was associated with the WebAssembly memory for the pixel data. But this is the entire WASM memory. This buffer just equals the WASM memory. And so if I don't specify that I want the same section of memory that the other array is working with, it doesn't take it. Which is just like, I mean, I guess it's on me, right? It's always on me. But like, how the, like, that's such a, I would never have guessed that. Like, that's why initially I started with this. Is because I thought it would, like, yeah, that's fucked. Okay, whatever. It's fine. Now we know. But fuck that noise. And it's also kind of fucked that you can't, like, there's no safety net here because the WebAssembly memory is like read writable. And from Zig, like, in Zigland, if you define something as constant, like this string hello, should be constant in the binary, right? It gets copied into WASM memory and is just writable from JavaScript. It's like, oh, that's so fucked. Okay, that's fine though. It's whatever. It's fine. I'm not unhappy. You're unhappy. So now we should at least be able to figure out why it's fucking crashing. So okay, let's try to get rid of some of these console logs that are useless now. Okay, console log, get rid of this guy. This is annoying. We're chilling now. Okay, so we have 800 by 600 for the width and height. And then here we have negative position somewhere. Where the fuck is that negative coming from? It's the platform x start norm. So platform lock minus platform width normalized over 2. So what the fuck is going on there? State platform lock and state platform width norm over 2. Let's just figure out which of those guys is fucking up. So my position is 0.016. Oh, is it because when we... Let's turn off this step function. This is now 0 and 0.15? That something about this doesn't feel right to me. Can we call log state here? Chamber instance exports log state. Is it just like fucking broken somehow? Yeah, somehow the platform location is changing when I'm not expecting it to. So what the fuck is going on there? Probably more invalid memory access from somewhere. Okay, so who could be fucking us? Who could be fucking us? We log state here and it's fine. Then we call alloc. And then let's try logging it again here. Chamber state. Is it immediately fucked after we allocate? Interesting. No, wait. What the fuck? Console log hi. And put it down here and say bye. What's going on there? Oh, here we go. So here it's still fine. Here it's still fine. Okay. Did you set a small max memory? That's possible. Very possible. Very possible. I didn't set anything, so it seems possible. I would just expect someone to error out in that case. Oh, fuck me. We're not null checking our alloc. Which would be really bad. Chamber pixel data. We should write that number down. We should say chamber pixel data. No, that's fine. That's fine. So there's nothing too crazy going on there. Okay. So here though, doesn't feel right. Is the chamber state like console log chamber state? Like, is this like what the fuck is going on here? Null. So when we set the chamber state from down here, oh fuck me, man. Oh, I wrote const here. Fucking shadowing, man. Oh my god, that's so fucking annoying. Okay. Oh, god fucking damn it. I hate everything. Fucking garbage language, man. It's not the language's fault. It's my fault. It's always my fault. I know. But fuck my life. All right, let's uncomment this whole function again and see if it works a little better now. There's our platform. Oh, it's my fucking mind. It's fine. Don't worry about it. Final ever example of why Zig disallows shadowing. Yeah, I mean, I deserved that. Okay, so let's try now rendering this in a loop again. So window set timeout render chamber 16 milliseconds. Let's just kind of see what happens. Okay. Well, that did something. The platform's definitely moving and definitely being rendered from Zig. For future reference, couldn't we use the native browser debugger to make this less painful? Maybe. I mean, I didn't really have any guesses to what the problem was, but okay, maybe I could have looked. Okay, so we've definitely got a bug here on the turnaround shit. Oh, because we didn't invert the direction. So here we have to say state platform direction is equal to left. Can we like do this? Just is this legal zig? And then do. Can we do this? Like, I wonder if that's legal. No, obviously not. Obviously not. Okay. So I guess we'll just do this. We'll say, hey, we have this enum, and we have some function. We said, can you set functions in this? Flip. Is this legal zig? I don't know, but we'll just find out. If self is equal right, self equals left. Else, right. Then we flip it. There you go. Okay, so there's a bug here now where we're going out of bounds. We're not clamping the drawing here, which we need to do, so we need to clamp the platform x start norm is equal to clamp. Fuck, there's no clamp. Min max 0.0 and platform x start norm. These become variables. And we do the same for end, but clamp it at 1.0. And now are we chilling? Chilling. Absolutely chilling. Okay. That's not bad. That's actually like, we had a lot of like annoying bullshit in there for sure. We only did one of the many things that we planned on doing today, and it took us a whole fucking 2 hours. And this is, I guess, a direct result of me not knowing JavaScript very well and not reading. But I think overall, this is pretty cool, right? So what have we done here? We have a WASM module that we've compiled from Zig. This guy allocates some memory that we feed into the canvas data for rendering. And in this memory, we draw this line representing this like position of this thing. And every step of the like simulation, we move this platform by some amount. So the next steps here would be, we actually want the movement of this platform to be like handled by the server. So the next steps are to basically put this same module and run it on the server as well as the client. And then just do like the step function on the server side and send some data that represents the internal state up and like handle serialization and deserialization somehow. Not sure how we're going to do that yet, but that's for tomorrow. That's fun for tomorrow. Does it go past the other screen? Yeah, but I don't really give a fuck. It's using the center position of the platform like Elysium said, so I'm not really too worried about it. It's like, as long as it's like not rendering past the edge, it's not causing any problems. Okay. So thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. So 2 hours ago to now, 2 o'clock to 4 o'clock Pacific time. If you're new here, there's a YouTube link in the Twitch description where we have playlists breaking up all the projects we're working on. Right now we're working on this collaborative Rube Goldberg machine, but we've done other stuff: video editor, QR code decoder, operating system, 3D stream intro screen, neural network for stuff. I don't know, just whatever. You can go check it if you want to. Who fucking cares? If you're on YouTube, there should be a Twitch link in the YouTube description where you can swing by, say hi if you're online when we're online. Like, subscribe, Twitch Prime, and buy YouTube and Twitch. Let's figure out who to raid.